ASMR mode anymore. You there? What's up, Waleed?
Hey, how's it going, Dimitri? Yes. Are you doing all right?
I'm doing great, man. I'm blissing out now after that one.
Oh, yeah. Now I'm all soothed.
There we go. There we go. Stretch it out if you need to. And wow, awesome. So, everyone is very clear headed now, I believe, for your talk. And they are ready, but we need to just school them on the fact that there is an Anyscale Ray workshop happening in person once we finish this conference today online, and it is happening in San Francisco. So we actually filled up the full conference. Sorry, the full workshop. The conference is pretty full too. I mean, there's like 2,000 people online right now. So that's pretty full, I would say. But we filled up the workshop. There's like 50 people on the wait list. I'm not going to be the guy that says it, but I bet if you just show up and you slip the doorman 100, you'll get in. All right, that's all I got to say. Waleed, take it over, man. It's all yours.
Hey, thank you very much, Dee. It's really great to be presenting at MLOps community and LLMs in production. I have an update. Obviously things have moved very fast in the industry. But the last time I talked at an MLOps event was a few weeks ago, 2 weeks ago, and we were just giving people a preview of Aviary. And now what I hope to share today is our first 2 weeks of the painful lessons we've learned building it, deploying it, and getting it running. So what I'll be talking about today is really about the lessons we learned. And this is one of my favorite quotes, which is that experience is a good school, but the fees are very high. So my goal today is to avoid you paying some of the fees that we did. So if you learn some of the things about what it takes to really deploy LLMs in production, or at least our experiences from it, then I will have done my job. So we're going to start off with something very simple, which is, there's lots of different ways to focus, how you deploy LLM in productions. But the ones we'll be talking today about are self-hosted models. In other words, you as an organization run and maintain the model, usually based on an open source foundational model. That you've fine-tuned, or maybe you're just using it as is. But first, let's dig into the question of why you would want to use, why would you want to self-host anyway? Second is we'll talk a little bit about our exploration and what we built, something called Aviary Explorer, which has been out now for 2 weeks. And then we'll share some lessons that we learned the hard way, right? First one is model selection is tricky. Serving LLMs turns out to be pretty hard in many ways. Be prepared for deploying more than just a single LLM, understanding the importance of GPU RAM, and finally, how do you keep costs down? And what we'll be doing is we'll be giving you a little bit of a behind the scenes look of how it works. We'll be showing you our dashboards, our tooling of our live production service, just to give you an idea of what we learned during this process. So the first question I wanted to discuss was really, and one other thing, we'll be doing lots of demos. So hopefully the demos don't die. So when you try to deploy an LLM in production, you really have 3 different choices, or 4 choices, but I think the 4th choice is kind of very rare. So you can either go to a commercial company like OpenAI, Anthropic. You can go to a hosted open source solution like Hugging Face, Mosaic, Octo AI. And again, these slides are super fresh because the Octo AI just launched yesterday. We'll talk a bit about Aviary coming forward and how you can do that. But Anyscale is the company behind an open source project called Ray, and as well as a managed hosted service called Anyscale. And what we'll talk about today can work both ways. So everything I'll be showing you, except for one small thing, is completely open source, and you can have a play with it. The third option is really self-hosted. So usually what you'll do is you'll take an open source language model, like the language model du jour is, of course, Falcon, with its 40 billion parameters and the smaller 7 billion parameter model. And then you'll either deploy it as is, or you'll do your own fine-tuning on top of it. There's a small fraction of companies that are building their own LLMs from scratch, but I don't think that represents the majority. For those companies, they often end up using Ray with both OpenAI and Cohere, who are building those commercial applications using Ray. the open source toolkit that we've made available for distributed computing to train their models. But that's not going to be the focus today. So why would you want to use self-hosted LLMs? And the way we think about it is we're big fans of self-hosted LLMs at Anyscale. But we're not blind fans to it. We use GPT-4 for some things, and you just want to deploy the right tool for the job. But in particular, I think the advantages of OSS LLMs is you have control over your data. You might have regulatory restrictions, and you might just decide that LLMs are a competitive advantage. And I don't really want to share it with a potential competitor. Who knows what OpenAI is going to do next? Second reason is cost. And GPT-4 at the high end can be very expensive at 10 cents per 1,000 tokens. So we work with a company called Kappa, and they help us with document search for Ray documentation. It works really great. The only problem is that they charge us 25 cents per query, which is just ridiculously expensive. But they don't have a choice because the back end is GPT-4. So we want to be careful about costs. You never want to be in a situation where your vendor has locked you in, because that removes your negotiating position when it comes to cost. And finally, customizability. So you want to do things like fine-tune your models, but if you go to the commercial companies like OpenAI, they will charge you 6 times as much for serving a fine-tuned model as a non-fine-tuned model. So the one area that I think open self-hosted LLMs are not quite as good is quality. And this is something that's changing. There was a really interesting Google paper that said we have no moat, and they actually plotted the graph of how quickly open source quality is improving. Testing is starting to show that the gap is narrowing. So that's from places like LMSys and so on. And finally, we've been running some experiments. We're not ready to share the results yet because they're a little bit preliminary. But what we're seeing is open source is perfectly good enough for things like summarization and retrieval assisted generation. So it's not that they're plug-in replacements for the full power of GPT-4, but if you think carefully about your use case, you may be able to find a good fit. So just trying to summarize these options here, this is a chart that I hope you find useful as you're trying to choose, when do I use commercial APIs, when do I do self-hosted, and what the pros and cons are. Clearly, for example, the hosted approaches are easier to use. Self-hosted has some risks. Obviously, what I'm trying to do and what we're trying to do with Avery is turn this sad face into at least a neutral face, if not a smiley face, to make it easier for people to build self-hosted models. So now let's dive into the lessons. The first lesson is, wait a second, it's great that you have a self-hosted model, but how do I choose the right OSS model? What size do I need? How much does each option cost? Where are the quality characteristics? Some models come with up to 4 tunes. Which of the 4 tunes do you use? So the first thing that we did is that we built some tools, and I'll walk you through those tools right now. So the first is Avery Explorer, and that's you can try this out yourself at avery.anyscale.com. And so I'm just going to give you a quick overview of Avery, the tool that we built, and then we can. I'll also show you some of the command line tools that we built. Right. So this is Avery. And as you can see here, it allows you to choose different LLM models. You can choose different characteristics. We have certain options, like you can choose the fast option, which chooses the fastest LLMs we have. And then you can just quickly type on like whatever you want your prompt to be. And you can click. And then very quickly, you can compare these 3 LLMs and see which ones you find personally more acceptable, which ones work better. The latency is going up, I can see. Probably all of you are hitting the website soon. We'll see if we see the spikes. But you can see that the outputs of each of them, and importantly, we can measure things like the latency, the cost, and the tokens per, how much each of these models costs. And so that gives you a quick overview if you just want to kind of see on the surface. Of course, it's also possible for you to load your own models. So what you could do is you could also have fine-tuned versions of your own models that you put into this list, which we'll talk about later. The other thing we're able to do is very easily to kind of, we've allowed people here to vote. So, I might come here and say, you know what? Well, this one doesn't have 5 books in it. So maybe we'll just choose this answer. And this one's too verbose, so I'm going to choose this answer. Now, imagine what happens if we have people around the world filling that in. And what we can build is we can build a leaderboard of like, what are the best LLMs for this particular use case? Not only can we build a leaderboard, and there are other websites that have leaderboards, but I think one of the unique characteristics for us is that we've tried to characterize things like the cost, the latency, and so on, so that you can build a model. Now, there are some simplifying assumptions here, particularly that it doesn't fully include batching, and batching can have a 10x impact. So think of these as an upper bound. But what I can do, for example, is I can sort by the fastest, which also means the cheapest in terms of generating outputs. And you can see that Amazon Light GPT is pretty fast, but unfortunately it doesn't rank very highly on performance. Whereas I think the superstar and some of the models that we're seeing people want to use are things like like the chat model from Mosaic ML or Open Assistant. So let's have a look at those, what it looks like, in terms of the cost. And we see, not surprisingly, like that those are some of the most expensive ones. Mosaic Chat is not too bad. But you can also see that part of the reason that something like Storywriter or Open Assistant are so expensive is not because it's the cost per token is high, but it's things like Open Assistant likes to generate like long answers, and the same thing for Storywriter, which is what it was fine-tuned for. So we hope that you will find a tool like this useful in your selection of the appropriate model. Let's go to a live demo. That's just the UI version. But what we can also do is we also have some command line tools. For example, what you can do is we've created this Avery command, and then Avery backend can list all of the different models that it has available to it. This is the same model that you folks are hitting really hard right now. You can get a list of models, but what you can also do is you can, let's say that I have a bunch of prompts. So I'm going to look at something like example/QA prompts, right? I'm just trying to, what I might be doing is I might be working on a trivia bot, and I want to work out, are the answers good or not for these different questions. So what I can do is I can actually now run a query on this. And what I can do is just compare two outputs. So we said that Mosaic was a good one. We've also added a capability to compare with OpenAI. And it takes that input and it's now just going to sit there and process it, sending the Mosaic MLs to our backend, and at the same time, just sending those same queries to OpenAI. So that will take a few seconds, but very soon we'll be able to get the results there. And so we've asked it a few trivia questions, and now it's going to hit OpenAI to just show us what the results possible there are. But you can see this tool is kind of making it much easier for us to evaluate what the open source options are. And yeah, so that gives you an idea of like how we approach the problem of how can we help people understand what the right LLM model for them to use is. Cool. So I'm going to continue now. Hopefully, if we have time, we might see what the results are there. But then the funny thing happened as we were trying to build this application. And that is that we found that deploying LLMs is harder than it looks. It's one thing to say, oh, that's a really great app. And then, that's very fun. But really think about what it took. It took, what we found the hard way was managing this aviary, so to speak, of 12 models was giving us headaches. And the initial assumption might be that what you just got to do is I can just download the model from Hugging Face and run that. And what we found is that it's much harder than that. You have to think about different definitions of roles, different markers, all that kind of stuff, different stop tokens, different accelerators that work for different models. Some need more GPUs, some need more GPUs, as well as support for things like batching and streaming. So that's the challenge we faced. And as we thought about it, we thought, maybe there's a way we can define a configuration that allows us to specify what we want and to prepare each model for production. And we were really excited about this because once we added this kind of model config abstraction, Demetrios, is everything okay?
you you knew I am the bearer of bad news. Yeah, you were just sharing. You've been sharing Avery this whole time, and you didn't share the CLI. So I'm
Ah,
realizing now that there was a few things that people missed out on.
okay.
But
So
there we
yeah,
go. There it is.
let me rewind. Sorry for that,
Yeah,
folks.
that's all good, man.
Um, so yeah, as I said, where we were was we ran this model. We tested OpenAI versus MPT, and it generated the output for us. So let's put that model in a file called qa.json, and it has all of the statistics of each of the models. What was the difference between one? And we've also added a command called Avery evaluate. And what we can do is, again, this is the time to use GPT-4, is send those input to GPT-4 and ask it which of the answers were better. And very soon that should be able to produce a result for us and print a table that shows us what it thought the best results are. So hopefully that has given you an idea of some of the capabilities, and I apologize for the issue that we saw earlier. And I will remember to hit the share the tab button in future. Cool. So just in a moment, it will print a table, and you can see that it's basically scored each of these inputs and compared them. And in this particular case, this evaluation thing is still something that we're fine tuning, but it gives you you can see looking at these results that actually the open source results are not bad at all. Like they're actually very good for this particular type of application. All righty, let's go back to the slides and hit the share tab instead. So as I was saying, really, as a result of thinking about things in terms of model configuration, we were able to add support for a new LLM that came out in about 5 minutes. So let's have a look at those models and what one of those model configs looks like. So what we can see here is that we have a little config file for each of the different models. And you'll see that, in some ways it's very similar, but you'll notice things like this. They'll use different strings to denote, what's the start of a string and the end of a string. If I compare it to the one for Mosaic ML, there's all this fine tuning you have to do. There's all of these settings that you have to make about, that use it slightly differently. Yep. So you can see that there's differences in what we are trying to do, and the tweaks that we have to make to get particular models to produce reasonable values. But what we've done is effectively there's a little model config for each of the different models that we want to run. And ideally, and what happens a lot of the time is you just modify the model config a bit and it's able to run your new models. Or say you have a fine-tuning model, you can do something like that. And it's just a change of the direction. Cool. So the third lesson that we learned was that you're probably going to deploy many more models than you think. So we thought at the beginning of this that we might have like 3 models. We might have like a small, medium, large. But very quickly, we found that we wanted to add more. Maybe there's different sizes. Maybe there's different fine tunes. Maybe you want to do A/B testing. And the other thing that we're seeing on the horizon is that there's a router design pattern where you don't have a single LLM, but you might have like 3 LLMs fine-tuned for different things. And then you kind of have like a router LLM that decides which of the 3 LLMs to call. Now, just that simple configuration, already we're talking about 4 LLMs. Cool. So very, very quickly, we started to realize that managing multiple models was very, very difficult. Each has different requirements and everything we needed. And could we make it so that deploying a new LLM was no harder than any other microservice? And that was really the genesis of the Aviary backend. And as you folks know, this is an LLM, there's kind of a very important DevOps principle, which is that you treat the things you're working with like cattle, not like pets. You don't have cattle, that you still care for them, but you care for them as a group. You don't ask a cow to come sit on your couch the way that you would ask a pet to sit on your couch, right? So this principle of treating LLMs like cattle and not pets really simplifies the management. And the declarative approach that we took of the model configs also simplifies that. So a model dies, it's okay. You can just load it from the model config again. It dies, Ray serve, and Ray, which is what the system is built on, has really good fault tolerance. So if one of the servers dies, it'll just bring up another one. And because of the features built into Ray and Ray serve, it's super easy. So what I'd like to do now is just show you a little bit about the real backend that's actually serving avery.anyscale.com. So I'm going to click on share this tab instead. This is showing you the Anyscale, and right now the backend that you're seeing is actually this guy. And you can see that there's actually one service or one deployment for each of the different models. And then there's one kind of glue model called a router deployment that kind of holds it all together and redirects traffic. So this particular model, as we said, that's running in production, we're hosting 12 LLMs together, and we can click on any of them and get their statistics. But the thing that I wanted to show was just like the serve dashboard. So very quickly, you can come over here and you can look at, what are the statistics for like this service? What's happening to our traffic? And it looks like you guys have been busy. In the last 5 minutes or so, you folks have started to hit. And, we've gone from like 15 replicas to like 20 replicas very, very quickly. So that gives you an idea of like, how our backend works. We also monitor it in terms of like understanding how many users are using it. So I'm going to share this tab now. And this is, let me just do a quick refresh on this. This is our live traffic showing us, how many queries people have put in, what the token distribution is like. We realized that people were using us a lot for summarization, but also we notice that we're actually getting, you can see here just how spiky the traffic is. And that spiky traffic does not play well with LLMs, unfortunately. So this kind of gives you an idea of like, how it works, how we monitor it, how easy it is to switch. And, you can very easily, I'm switching tabs now. You can very easily, let me see if I can clear this. You can very easily kind of deploy new models with this format. So I might, let me try this. And we'll run locally. This will probably take a while, but I can just specify the model config file, models, and let's say Amazon Light GPT. And very quickly, this model will load it up. So again, it's this kind of character of kind of making it very easy to kind of deploy these models and handle all of that particular issues. Cool. So let's go back to the slides. Lesson 4, it's all about GPU RAM, not about compute. So we have this page you can check out called llmnumbers.ray.io, numbers every LLM developer should know. And what you realize is that GPUs, how we use them when we're building LLMs is we use about half of it for model parameters and then half of it for working memory for batching. And batching is very important for performance reasons. Processing, if you didn't do batching, for example, you might see nobody else sees me.
Don't let me distract you, Wally. That was for the people that are waiting for the next talk.
Okay, cool.
You keep cruising, man. You're doing great.
All right, great. So it's all about the GPU RAM and really managing that. So you need this memory for both purposes. And that means that you have to think very carefully about like how you lay things out in memory. So we often, how we dealt with that is we used bigger instances to allow for more efficient batching. So basically now we rarely use 16 gig GPUs. The A10Gs tend to be kind of our go-to GPU, and the A100s for the really big models like Falcon and Open Assistant that are 30 billion or 40 billion parameters. Often we'll need 2 of them because the parameters are so many they don't fit on a single GPU, and we'll run 2 GPUs in parallel. But the thing we're optimizing for is making sure there's enough GPU memory that we can do batching. And batching is where you might take 5 requests and send them at once to the GPU, which gets you much, much greater throughput at a small cost in latency. And so even it doesn't really matter which GPU is faster. What the key thing to focus on is really which GPU has more memory. And generally, the A100s can be a bit pricey, but even the ATGs, going from a normal 16 gig GPU, which might be slightly faster, to a 24 gig GPU will probably give you a better performance improvement. And final lesson, cost management. So I want to tell you that, every, we like to keep one replica around. We can actually do scale to 0, but that introduces, a minute or two every time someone uses a new LLM. So we keep at least one replica of each LLM around just running so that they can get good results. And if you have 12 models, that's essentially 12 GPUs we have to get running. I know it might sound high, but it's actually after optimization. You just have to be very, very careful when you provision. So you really need to be able to auto-scale up and down, but that's not really the key problem. Because if your auto-scaling time, is 15 minutes and you have a 20-minute peak, that's not going to be fun. So what we've done is we've really done a lot to kind of optimize fast loading and startup time. We locally cache the Hugging Face models, and we might use NVMe drives. These are very fast local drives to help accelerate that. You don't realize it, but Hugging Face, like any service, has variations in how long it's taking. So if you can run a local S3 and manage a local cache, then you can absolutely accelerate how long it takes for a node to come up if you're auto-scaling. And then the second thing is, this is the one part of this that's not open source. On our proprietary AnyScale service, we've optimized the crap out of starting up nodes, and we can start up nodes in like under a minute. So that's kind of within your system, you can optimize your fast startup time, or you can use AnyScale to do that. Cool. The other thing is that we very carefully fine-tuned the auto-scaling parameters. And we took advantage of raise serve capabilities, which is a very flexible system. So you'll see if I go and we have a look at one of those files again. And as we saw earlier, I just started a service with nothing more than an aviary run. And now if I do just the aviary models, it will tell me the list of models, but now I'm going to tell it that I want to use the local aviary host. And sure enough, we should see our local model. And our local model running on this machine only has LightGPT running on it. So it makes it very easy to load things up. But just looking at the dashboard over here and looking at the peakiness of the traffic, you can see that there's lots of variation. So if I look at the last 7 days instead, you can see that there's a lot of spikiness there, and we have to tailor for it. And so the way that we've done that is we've made it so that you can specify, what are the minimum number of replicas that you want? How often do you check to see what the look back is? So how frequently you're looking at those statistics, and also bias towards downscaling slightly slower, which costs a bit more, but it really prevents those types of peaks that you can't handle. So let's draw to conclusions now. What we've seen is that self-hosted solutions of LLMs have some advantages. If those advantages align with your particular use case, then it's a really good idea to use self-hosted options. But there are some things you need to pay attention to. You need to choose the right OSS model. You need to really think about what it takes to serve a model. you got to expect that you're going to be serving more than just a few models, and really think about GPU. And keeping costs down means you have to have things like auto scaling. You need to fine tune them. Now, as I mentioned, everything that's part of Avery, except for that one little thing, which is fast node startup time, is open source. The UI is open source, the CLI is open source, the backend is open source. And so you can help us to build for the MLOps community a tool that allows them to more easily do self-hosted models. And so what's next? We're adding features like streaming, continuous batching, and more LLMs. So the key follow-ups here, you can try it out yourself. There's a open source for the whole thing. And if you want managed Aviary, just drop us an email. And if you need some numbers to help guide your process of putting things in production, have a look at llmnumbers.ray.io. Thanks.
Dude, that numbers is so cool. I love that you all thought of that. And I would expect nothing less from you, Mr. Wally. That is just quality right there, man. And the, like, one question I had, that dashboard that you showed, that was basically, you had to set that up. Everyone is going to have to set up their own of those, or that comes right out of the box with Avery?
So we have a public one that anybody can use at any time. If you want to run your own and choose your own models, you can do that too. We expect people to run their own Aviary. We've made it very easy. We can just give you a quick account and you can set it up on Amazon AWS very quickly. It just requires a Ray cluster to run.
Dude, so there are a few questions that are coming through here, and we are horribly late on time, as usual. So the panel that's coming up, they're being very patient with us, and because there's just too many good questions in here for me not to ask them. That was a great presentation, man, and awesome demo. Can you, okay, does it make sense to predict peak times and scale the cluster in advance? Is that possible?
Yeah, if you can, do it. What we found is the peaks are very, very random. You don't know what time zone someone's going to is interested in your system. We had an article come out yesterday, and all of a sudden the traffic quadrupled to the website. So the dynamic approach is probably the safer approach. But yes, if you want to, you can definitely just kind of say, I'm going to, between 4 o'clock and 6 o'clock, I want you to have 2 replicas instead of 1.
Yeah, exactly. If you can predict the future, get on it. There you go. That's basically the understanding that I got from your answer.
Yeah, and if you can advise me on stock trades, that would be even more amazing.
Yeah. Awesome. So last one for you, Waleed, and then I'm going to ask you to jump in the chat. And also, Waleed is on Slack, so if anyone wants to ask in the community conferences channel, just tag Waleed, and he's in there. But Gilad was asking, what would be the metric that auto-scaling is configured on? Traffic? How would you differentiate high memory consumption due to lots of small requests from a few large ones? Great question.
Yeah, I think that's something that we're still working on fine-tuning. One of the tricks with LLMs that's very different is, a 2-word answer, maybe a very short prompt has a very long answer. And that's where things like continuous batching become very useful. Because if you have continuous batching and you have streaming, it kind of evens that out, right? It's just, what rate of tokens am I getting in and what rate of tokens am I getting out? And if you can model that, you can do that to more accurately predict things.
So good. Well, everyone, I am going to also, before I kick you off, Waleed, I want to say that Anyscale is an incredible sponsor of our LLM in production report that we just put out. So go get your hands on that, and thank you, Anyscale and Waleed. I gave you a whole lot of shit when you came on the podcast for not sponsoring, and you pulled through. You made it happen. You moved some budget around. So in case in case Avery goes out, it's because they probably spent too much money on this damn report sponsoring the community. So we need to help them. We need to help make it as reliable as possible. Waleed, dude, thank you so much, man.
It's been a pleasure.
This has been awesome.
And I'm really eager to answer your questions. Just drop me an email or just I'll be online on Slack to answer your questions too.
There we go. There we go.
See you later.
All right.